All right, guys, today we're going to move into a new topic. We're done with net change and all that good stuff. We're going to talk about area for the next couple days. Today we're going to be focusing on finding the area between two curves. We've already found area between a curve and the x-axis, but now we're going to learn how to find area that exists between two curves. So, for instance, suppose that I have this function up here, f of x. And suppose I have this function here, g of x. And I want to find the area that exists between them. Well, the way that we're going to do that is by finding the area underneath of f, finding the area underneath of g, and then subtracting the g function's area away from the total f area. Okay? And so the way that that's going to look is we're going to find the area under f from a to b. We're going to find the area of g from a to b. And I'm going to subtract the area underneath of it from the area on top. Now, we could use our properties and put these together as a single integral, like this, as well. So basically, the way that you find the area between two curves is by starting with the function that's on top and subtracting from it the function that's on the bottom. And you just go from whatever endpoints you need to. And that will tell you the area between the curves. So let's go ahead and formalize that here. So now instead of saying on top or bottom here, I just put f of x is greater than g of x. But what that really means is that f of x is on top and g is on the bottom. F and g are y values. So if this y value is greater than this y value must be higher than this y value, which means that it's on top of it, right? So there you go. That's how you find the area between two functions. Just subtract them and integrate. So let's go ahead and we'll start off with our first example here for the day. I want to find the area that exists between these two functions here. Now we could do this by hand, and in fact I'm going to devote an entire lesson to doing these problems by hand later, but we're going to start off with just using our calculator. So the first thing I want to do is I want to graph these two functions. So let's do that. The first thing we're just going to go y equals, and we're going to type the functions in there that we see. All right, so here they are. This is what they should look like. And once again, if you need to ever adjust your window, you can. Now what I want to do is I want to find the area between these curves. So that would be this little region right here. Okay, I have my curve on the top, and then I've got the curve on the bottom of it, and the area between them is in yellow there. And that's what I want to find. So I want to find that yellow region. Now to do that, though, I need to find where they're crossing, because that determines my starting point and my ending point. So step one is to find where they cross. Okay, so let's do that. I'm going to, how do we do that? We've done that before. We're going to do it again. You're going to push math. Actually, no, I take that back. You're going to push second. My bad. Second. And then you can push calc. And you're going to go down to number 5, or you could just press 5 to where it says intersect. And basically, you just put your cursor as close to where they're crossing as possible. And just push enter 3 times. Okay. Now, this is a weird number. I don't like it when we're calculating. I wish they didn't do this, but look at this number, 1.226 e times 10 to the negative 15th. That means we have 1.22 times 10 to the negative 15th power. And what that basically means is that you would move the decimal over 15 times. I'm not going to write it all out, but basically that's a really small number. Guys, you know what that means? It means it's 0. So if you ever see that thing where it has an e in there with a number next to it, especially if it's a negative, that negative exponent, that means it's just 0. So the x value there is 0. What's the other crossing point? Well, let's find it and do it again. So we're going to do second, Calc 5. Now we're going to scroll to where they cross again. And it's 6. So they're going from 0 to 6. That's where they're crossing. They cross first at 0, then they cross at 6. Now it's also important that you know which function is on the top. So as you guys can see here, let me show you here. I'm going to scroll backwards here a little bit. We're going to push trace, and it will trace a function. Now right now you guys see my cursor is tracing the parabola, and the parabola is the y1 function, negative x squared plus 4x plus 5. So that means that it's this one that is on top and this one is on bottom. So we might want to label that. So in this case, we know that this one's our top function and this one's our bottom, and you can figure that out by just using the trace button on your calculator. All right, so we know where they intersect. They intersect at x equals 0. We know they intersect at x equals 6. So it starts at 0 and it ends at 6. We know that this function comes first. We'll call that y1 and we'll call this one y2. We're ready to set up our integral. And so my integral is the top function minus the bottom function. And we're going from 0 to 6. And that will tell me the area in between those two curves. So let's get out of here. We're going to do math 9, going from 0 to 6, y1 minus y2. dx, enter, and there's my area between the curves. And so the answer would be 36. And that's how you find the area between the curves. So you find where they cross using your calculator. You can find out which one's on top using your calculator, and then you do your setup and solve. So find where they cross, know which one's on top, do your setup, and solve. All right, so let's go ahead and have you guys try one of these real quick here. Homework problem number 1. Go ahead and pause the video here and see if you guys can get this one. So this is what it would look like if you guys graphed it, and it looks like they're crossing somewhere in here, but it's really hard to see. So I'd recommend using the zoom on this one to see a little bit closer what it looks like. I like zoom box. So I'm going to push zoom box and then drag a little box around this. I'm going to put my cursor up here and push enter, and then I'm going to drag down. And then I'm going to go over, and as I do that, it creates a box around the area that I want to see. And I push enter, and it'll give me a closer picture of what we're looking at. Man, that's really still barely, they're barely touching each other. That's crazy. But it looks to me like in that region where they're crossing, the straight line is above the curved line. It just barely grazes into it, stays on top of it, and then grazes out below it. So the region where they're crossing is right from here to here. So let's go ahead and see if we can find those places where they're crossing. I wonder if we could zoom in again just to kind of get an even closer picture. I don't know if it'll let us do that again. Pretty darn close. There we go. Nice. It's a sliver of area. It's barely anything at all. All right, so let's go ahead and find where those places intersect. Oops, wrong button again. I do that quite often. So 2. If you ever get a weird number, you could store it in your calculator instead of writing it down. And 3. Those are nice, convenient numbers. I can remember those easily. All right, so we're going to go back to our thing. Back to our graph, actually. We want to know which one's on top, right? So we're going to push the trace button, and we're going to see which one's on top. And right now we're tracing the bottom function, and the bottom function is 6 over x. So the one that's on top is the 5 minus x. The one that's on the bottom is the 6 over x. So what we want to do is we're going to have the y1 functions on the bottom this time, and the y2 function is the one that's on the top, and we're going from 2 to 3. And that's the integral we'll type in, so let's do that. Should be a very small amount of area if I'm not mistaken. That's pretty darn tiny of a sliver of area. I'm getting 0.0672 is my final answer there. All right, so that's homework problem number 1. Let's go ahead and move along to our next one here. Now sometimes whenever you are graphing these things, they cross at more than 2 points. So what do you do then? Well, as you guys can see, in the first half, the blue function, the f of x function, is on top. So if I'm integrating from a to b, then it's going to be f minus g. But for the second half over here, as I'm integrating from b to c, the red function, the g line, is on top. So this one will be g minus f. Okay? And so if you wanted to find the total area, you have to add these together. So here's the point, is that when functions cross more than twice, in other words, when you have more than just a beginning point and an ending point, and they actually cross somewhere in the middle, then you're probably going to have to break it up into separate integrals, because usually when they cross, they switch places. For this first half, f is on the top, but for the next half, g is on the top. And so you have to reverse them. However, I've got some great news for you. Since we're doing our calculator today, what does 5 minus 3 equal? That equals 2. What happens if you reverse it? It's the same answer, it's just negative 2. So what if we go ahead and put absolute value bars on these? They are the same, right? So in other words, if you were to put an absolute value bar on this and an absolute value bar on this, then these two things become identical, and then you could just put them together as one integral starting at a and ending at c, and you don't even have to worry about the middle point because the absolute value takes care of the place where they switch, because the order doesn't matter in that case. Okay, and so that's how we're going to handle it today. Now when we start doing some of these problems by hand, we'll have to be a little bit more creative. But for today, since we're using a graphing calculator, all you have to do is start at A, end at C, do F minus G or G minus F. It really doesn't matter so long as you've got the absolute value bars on there. When we do this by hand in lesson 7.6, we're going to have to find all 3 points of intersection, and we're going to have to create different integrals for each interval based on which function is on top versus which function is on the bottom. So here we go. All right, so I'll show you guys the real graph of these functions in a minute, but right now I just want to give you guys a brief understanding of what we're looking at here. We have 2 functions, negative cosine and positive cosine. It would probably look something like for one of them, and for the other one it would look like this. Now, sometimes though, like, you don't have to find the points of intersection though. Like these, for instance, these things are just going to keep crossing over and over again because they just kind of keep wiggling up and down. So what a lot of times they'll do on these problems is they'll tell you where to start and stop. So they want us to start at negative pi over 2, which would probably be like, I don't know, 0, 0. I don't know. It's kind of hard for me to estimate. I'm just going to put a line right here to say that's negative pi over 2. It's not technically right, but we'll just say it's that. I'm just kind of rough hand sketching this graph. And they want us to stop at pi over 2. So that's over here. So that's going to be my starting point. That's going to be my ending point. And as you guys can see, they do intersect in the middle there somewhere. And typically, if I was doing this by hand, we would have to do one integral for this area until they crossed. And once they crossed, we would have to do another integral for this area because which one's on top and which one's on bottom switches at that point. But since we're using a calculator today, we can handle this very easily. We just need to start at the starting point and end at the ending point. And we just need to take the absolute value of my two functions. Let's call this one y1 and we'll call this one y2. And the order doesn't matter when you take the absolute value. Okay? And so it's as simple as that. And so from here on out, I'm just going to go ahead and let my calculator do the rest of the work for me. -2 cosine of x, we decided, was going to be y1. And then +2 cosine of x was going to be y2. We're going to do our integral. Oops. Going from -pi/2 to +pi. We want the absolute value on there though, so we're going to push math, we're going to go over to num, we're going to push 1 for absolute value, and we're going to do y1 minus y2. And once again, anytime you have absolute value, it makes your calculator think a little bit harder than normal. But we can go ahead and give it some time, and there it is. So we can basically just round our answer to 12 and say the answer is 12. So the area between those curves is 12. Now, if you wanted to graph it and actually take a look at what those functions look like, I'm going to have to change my window here because for the last problem I had, it was a little bit off. By the way, when you're dealing with trigonometry problems, you might want to use option 7 because it sets the window to an ideal viewing for trig functions. This is what the graphs actually would have looked like. And pi/2, actually, I know it would be right about here, but you could plug it in to find out. And then pi would actually be here. So we're finding all this area right here, plus half of one of these over here. And that's the total area that we just found. All right, so let's have you guys try one of these. So here's your two functions, and I'm giving you the same thing I had. I'm giving you the starting point and the ending point. This is not necessarily where they cross. It's just that that's the area we're going to start from and end at. So go ahead and do that, and when you unpause the video, you will see the solution. All right, there's my final answer, 14.977 approximately. If you want to push y equals, you might be wondering how I did the cube root of x squared. I just changed it to an exponent. It's a lot easier that way. And there you guys have it. So let's move on to our next one. There's really not a whole lot special here. Maybe there's something secret that I forgot about that makes it special. But on this particular problem, there's really just nothing special about it. I don't tell you the starting point and the ending point. So you can assume that we're looking for the area in between the curves, so it has to be closed off where they cross at. So you're going to need to find the crossing points once again. So maybe there'll be an interesting little snippet along the way. We'll see. But go ahead and see if you guys can find the area between these two curves, and when you unpause it, I'll show you the solution. So there's the graph. That's what it looks like in trig view. I don't like that, though. I'm going to change my window a little bit so I can see a little bit more. I'm going to... let's try zoom and just do standard and see if that might look a little bit better. I'm not real sure if it'll look a whole lot better. There it is. All right. So basically, I want to find the area between these curves, and this is like a W shape, but my bottom, my W got cut off. So I think I'm gonna change. You don't have to do this. I'm just being picky, but I'm gonna make my Y values go a little bit lower. I'm gonna go down to -20, and that way maybe we can see where the W actually ends at. There we go. Cool. Looks a little bit better that way. All right, so as you guys can see, we have this function here, and then we have the W-looking function here. And I want to find the area that is enclosed between them. So I'm looking for this area plus this area plus this area. Now notice how they cross each other multiple times. So if I was doing this by hand, I would have to do one integral for the area on the left, one integral for the area on the right, and another integral for the area on the right side. I would have to have 3 altogether. But since we're doing this by hand, it's pretty simple. We just need to do the absolute value of y1 minus y2. Doesn't matter which one's y1 and which one's y2 when we do absolute values. And we also, oh, x, not t. And we also need to know our ending point and starting point. So I only really care about those two spots there. So we just need to find those. So let's do that. And how do we do that? We do second calc, intersect, and we're going to scroll until my cursor is at one of my intersection points. And I get negative 3.07. This time I'm going to store that value, so I'm going to push, I don't want to write that down and round it, so I'm going to push enter, and then I'm going to push store, and then I'm going to push alpha A. And that way my calculator will store that number under the variable A. Going back to my graph, we're going to repeat to find the other endpoint. So we're going to do second calc 5 for intersect, and we're going to scroll over to where they intersect again. Get as close to it as your calculator will let you. Enter 3 times. There's the other intersection point. Once again, I don't want to write that down, so I'm going to push enter. Then we push store, and then we push alpha, and then B. And enter. Now my calculator's got that stored. And so those are the values that we're putting in there. Now, if you're ever doing an FRQ, it's okay for you to put A and B here, so long as you define them. So you would actually have to write this down on your paper somewhere. You only have to go up to the third decimal place, but you do have to tell them what A and B are. You can't just put new variables on there without defining them. So we'll do that just for good practice here. But our calculator will help us actually find this area now between those two curves. So I'm going to do math, 9, and we're going to put A at the bottom because it's the smaller one, right? Oops. Alpha, and then A, and then alpha, and then B, and then we're going to do the absolute value of y1 minus y2. And that will give us the area between those curves at that point. Thinking. And we get 54.711. And that'll do it. Alrighty. And that'll do it for today. So let you guys go ahead and finish up the rest of your homework, and we'll see you next time.